Are we on? Oh, we're on. Good morning, and good to see you, and welcome back to another high touch, high tech lesson with me, Mega Manoa. And today we're going to be learning about some super duper looper awesome stuff called magnets. We're going to also learn about their force in which they attract different things that we call magnetism. But before we start talking about any of those things, let's make sure that we have the materials that we'll be needing for all of the experiments today. Okay, so make sure that you grab the bag that has these things. There is a little cup inside of there, a bag of Play-Doh, a bag of magnets, and a bag of other stuff. So that's the bag that we definitely need. Also, from your white envelope, grab yourself your little tiny racetrack. You'll see there's a little car and a finish line over here. We definitely need this for one of our experiments. And aside from that, these are things that are not included that we will be needing, which is a bowl of water. And since we're going to be using the magnets, also maybe look around the house and find things that are maybe metallic or non-metallic, just to see if our magnets are going to stick to it, because we're going to talk about what the magnet is going to be able to stick to. So in any case, magnets are really awesome, and I'm pretty sure you've probably used magnets in your life at some point, maybe playing around with it, or maybe, sticking things to the wall, kind of like maybe a picture of your family, a family portrait. Oh, look at the little Mega Manoa family. Yeah, maybe we'd, stick that onto the fridge, but usually we stick things onto the fridge that are magnetic, okay? So there's a lot of things that we always work with, and guess what? There's one that is already there ever since you were born that you don't really feel. Guess what it is? It is the planet Earth. Guess what? The planet Earth is just a huge magnet.
Wait. The Earth is a magnet? Is a magnet?
Yeah, that's a big surprise to me as well. Yeah, the Earth is actually a huge magnet. And the reason why is because right at the center of the Earth, there's a part called the core. And that's basically made out of mainly iron and a bit of nickel, okay, which causes it to have the magnetism, okay? And also, because of that, it makes what we call a magnetic field, okay, which is pretty cool. And that's what happens with a whole bunch of these other magnets. It has a huge magnetic field, the planet Earth. It doesn't just cover the Earth just to cover the Earth. It also protects us from a lot of harmful stuff in outer space, okay, like harmful radiation. It just protects it. No radiation, not today. And even solar wind. So from the sun, it shoots out this solar wind, and it comes towards the Earth. It could really hurt us, but the magnetic field is there to protect us, and no, not today, solar wind, not today. Yeah, so it's pretty awesome. It protects us. But not only that, we also use that magnetism to help us find which way to go. The way that we're able to do that is we use something called a compass.
What's a compass?
Great question. Yeah, a compass is just simply something that we use to help us find out where north is, okay? So north is a specific direction because it's being pulled by one part of the magnet. We're gonna go over that. But as long as you find out that one location north, you can find out all the other locations, north, south, east, west. Okay, so you can find out all these different locations or directions just by finding that north, okay? But that north is being pulled by the magnetic field of our giant magnet inside of our planet Earth. And so you know what we're gonna do? We're gonna build our very own compass. Here we go! All right, so let's make our compass. Remember, the purpose of a compass and the reason why people use it for hundreds of years is because it always pointed towards one direction because of the magnetic field of the planet Earth. Okay, it always pointed towards north. And if you have north, you got east, south, and west as well. Okay, so let's make our compass, and these are the very things that we will be needing to make our compass. First, grab yourself that bag of the magnets something to write with. This is one thing I did not mention in the beginning, but something to write with, preferably a Sharpie of some sort of permanent marker, the bag of Play-Doh, the empty cup that came inside of your bag, and this wasn't included, your bowl of water. So this is actually a really simple experiment. All you need to do is just grab the Play-Doh and take the Play-Doh out, okay? And just put that right in the middle of your, what do you call it, inside of your cup, and kind of push it down with your thumb, okay? Just push it down with your thumb, just like so, okay? And then in the bag of magnets, you're not going to use all of these magnets. We're only going to be using the super tiny one. Do you see that little silver looking one right there? That's the only one that we're going to be needing, okay? So just put the other two round black ones back inside of the bag, and we're going to use this for another experiment. We're only going to be needing this little guy right here. This is a neodymium type of magnet, and all you need to do with this is just go ahead and put it on top of your Play-Doh, all right? Okay, push it down a little bit so it sticks in, and you are basically done. All you need to do next is just put it inside of your bowl of water. And remember, the magnetic field, or the giant magnet inside of the Earth, is going to pull this towards that direction of the north. Because remember, the Earth has that north side, right? And also we have a south pole, so it's going to pull it towards that. So once you put it in, spin it, and you'll find it always go back to the same direction. So here we go. Put it inside. And even if I just leave it, you'll see that eventually this little guy will start to face the correctamundo way. So you can see it's kind of staying in one general direction. What you could do is also you could turn it and spin it and see eventually as to which way it goes. And try not to have it touch the sides, because the edge of the bowl might stop it from turning where it needs to turn, right? Because remember, the magnetic field of the planet Earth is going to pull it towards a specific direction, in which is the north, okay? And you could just keep on trying to spin it, okay? And one thing you could do is you could use a compass. Actually, there is a lot of apps that you could get on your phone that could help you find the direction of north. So a lot of these awesome compasses are able to help us to find out as to which way is north, okay? So that's what we're doing with this. After you find out which way it stops, whichever way is north, then what you could do is just take it out and take your marker and draw the letter N, whichever way it was pointing. And of course, use your compass, unless you guys have a real compass with you, right? And whichever way it's pointing, that is the north. So I got north here. But remember, like how I said, once you find out where north is, then you could tell where south, east, and west are. All right, so I have the north, and obviously on the opposite side is the south. So I'm going to write on the other side the S for the south. Okay, and to the right of the S and the south, so if you have north and south, top and bottom, right, to the right of that is your east. Okay, so I'm going to put here E for east, and then, again, if you look at it, north is on top, south is on the bottom, then to the left of that is your west. Okay, so right on top of there, I'm going to put W, which will be for our west. See? Just like that. So that's what you could do. And now basically you could just go ahead and put this back into the water, and you got yourself your own little tiny compass. Okay, just put it back in the water, right? And even try it, try spinning it, and you will always fall back to the same spot. And the reason why is because, well, the magnet inside of the Earth has that magnetic field strong enough to be able to pull our magnet to point as to which way is north. See, it's pointing back to the same direction. So in any case, boys and girls, that is how you make your own really awesome compass. All right, so now let's have a lot of fun with some magnets.
What's a magnet?
Oh, I totally forgot. I totally forgot to tell you guys about even what they are. So, yeah, what is a magnet? Well, magnets are these objects that have magnetism. Basically what that means is that they're able to attract, or basically pull, anything that has things like iron or other types of metal. It's able to stick to it, okay? Now here, I have a magnet, and here I also have a magnet. But do you notice, does that one look like a magnet? No, but this one does. That's because there are two types of magnets. There are ones that are naturally made in the planet Earth. That's why it's a rock, right? And this one is man-made, made by humans. And just to show you that they are actually magnetic, here are some things that are made out of iron, okay? Some paper clips that are inside of here. If I put this nice and close, whoa, you see how it attracts? That's that magnetism, okay? So it attracts, it pulls right to it, I'm not even holding that, okay? And same thing with our rock here. It's not just a regular rock. This is called a lodestone. Okay, and here I have some, again, paper clips that have iron inside of them. And as you can see, whoa, rocks don't do that usually, but this is a magnetic rock. This rock has magnetism. Remember, all that means is that it has the force to attract certain things. But remember, it doesn't attract everything. Like it's not sticking to my face. It's because I don't have the metals inside of my face, like iron and a few other metals that they are attracted to. Okay, now when you take a look at these magnets, again, they have that magnetic field, just like our planet Earth does, because there's that huge magnet. But the magnetic field, that pull, right, that they have, we can't see it, we can't hear it, we can't smell it, but we definitely can feel it. Especially when you push magnets together, you can feel whether they are pulling towards each other or they push away from each other. And also you can see whatever they are pushing or pulling, right? But that's what's so awesome about this, okay? Even though you can't hear it, you can still feel what's going on, right? Even though it's invisible. I mean, like, take a look at that. That's pretty cool right there, tell you what. All right? But not only that, another really cool thing, if you look a little bit closer at these magnets, all magnets have two sides, okay? So they have two sides, or what we call two poles. There is a north pole, okay? And there is a south pole. Here on my magnet here, I have an N, which is standing for north, and the S, which will be for our south. Okay, so all magnets have a north pole and a south pole. That's why our planet Earth, you've probably heard that we have a north pole, right? And then there is a south pole as well. Why? Is because it's a huge magnet. But there's something really cool about the north pole and the south pole. Usually whenever you have a north and a south, let's say you have two other magnets, right? North pole and south pole, the opposites always like to stick together. Watch, if I bring these two closer together, do you hear that? They stuck together because they are opposites. So whenever they stick together like this, there's a science word for it, which is called attraction. Can you guys say attraction?
Attraction.
Exactly, but that's because they are the opposite, north and south. However, if I have it north and north, the same poles, as you can see, it's, I'm really trying to push, but it's really not wanting to come together. They're like, look, ew, I can't, like, no, don't touch me. And I'm really trying to push here, okay? But as you can see, they are not attracting, they're not pulling together. Instead, they're pushing off of each other, okay? So whenever they push away from each other, like how we see here, because they are the same poles, that's what we call repulsion. Can you guys say repulsion?
Proportion. Repulsion. 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 Repulsion.
Exactly. So some really awesome stuff that we can see with these magnets, right? Whenever they are the opposite poles, they attract. Whenever they are the same poles, they repel off of each other. So, that's pretty cool, huh?
Magnets are awesome. Magnets are awesome. Magnets are awesome. Yeah. Magnets are awesome.
You said it! And you know what? Now we can finally have some fun with a whole bunch of these magnets. Here we go! All right, so let's do our first game with these magnets. All you need is this bag of magnets. Okay, earlier we had that little tiny neodymium magnet. Now we just have these two circular magnets. Go ahead and take this out. Now with this, we just want to see again about that attraction and repulsion that happens. And just to kind of recap a little bit, and you can kind of see it a lot better from this angle. Remember, whenever there are the opposites, right? Here we got a north and a south. Clearly, as you can see, if I push them together, I'm not holding this one. You'll be able to see it sticks, right? It attracts, right? But the reason why they are doing that, if I just put it a little bit closer, they attract, and the reason why they do that again is because the opposite poles always attract. They have that sort of attraction. However, if I flip this over, okay, now this side is the south, that side is the south, this is north and north. You could tell by the letters that we put onto there. Now, if I try to push these together, I'm not even touching this one. Let's see what happens. Ready? What? Do you see that? Oh my gosh. It's like, no, don't touch me. No, no. Now, I'm not even touching this one, but the force of these magnets, because the opposites don't like to stick together, they like to push, that's what's really causing it to go away from each other, okay, or repel, or as we call it, repulsion, okay, so there's that repulsion happening. Even if I try to force it, it's never gonna, you can see it's really, doesn't want to stick together, which is that repulsion. So again, with our first game, we're gonna do that with these two magnets, okay? So right now they're probably stuck together, okay? So what we wanna do with it is just twist it until you feel it not wanting to touch each other. Because, yeah, so what you wanna do is just hold it in your hand and take that and just go ahead and twist it until you feel that they don't attract. Eventually, they're gonna repel. And try to keep them together as they're repelling. And if I let this go, look at that. It's able to repel off of each other, because obviously if they just come together, or even if I leave it here, they're gonna stick. But at a certain point, if you twist it, they're gonna be the opposite poles. The north is gonna meet the north, the south is gonna meet the south. Okay, so again, all you need to do is just hold it with your fingers, turn it, and then you'll feel it at a certain point. Keep turning until you feel it start to push away from each other. And once they start to repel from each other, then try to keep them together and hold it with one hand. And then if you just let it go, see that? It's able to repel. Another really awesome thing that you could do aside from that repulsion launch, right, is you could just leave it on the table or whatever you have it on and just try to push it close together. So whenever you push it close together, it most likely will start to attract or even adjust itself so that it will attract. But try it so that before you let it attract, try maybe turning it so that it will instead push. It's kind of hard, but keep trying and try to find the spot where it's going to start to push. As you can see, oh, it really turned really quick, right? So try to find the area where it's gonna push or repel so that you can see that repulsion going on. So you can see on one side, it's going to repel, but on the other side, it's going to attract. So there's another really awesome thing you could do with this. Okay, so that's our first game. And the second game that we could do is still keep these magnets, but this time grab the bag of a whole bunch of stuff. Okay, so this bag came inside of the original bag that everything else came in. Okay, so just go ahead and take that bag, open it up, and this is where also you could find other things from inside of your house that are maybe metallic or non-metallic that you could try to see if they will stick to our magnets. So go ahead and take your magnets. You can actually keep them together, and the whole point of this is to see which one is magnetic or not. Or in other words, remember, these magnets stick to anything that has iron, okay, or other metals that it could stick with. So let's see if these have iron. Let's see if the rubber band, do you think the rubber band has iron? Nope, it's not sticking. How about this aluminum? Do you think it's gonna stick? Huh. Well, this is actually a type of metal, but it's not sticking, as you can see, because it does not have iron. Okay, what about this little tiny pipe cleaner? Do you think that's gonna stick? It's fuzzy, it shouldn't, right? But let's see. Whoa. Whoa! So as you can see, it's sticking. That's because this pipe cleaner actually has some iron inside of it. What about this little tiny seed? Do you think that has iron? I don't know, let's see. No, it does not have iron inside of it. Okay, what about the paper clip? Let's see, ready, set. Ooh, yes, that definitely had iron. You can see it's sticking. What about this little piece of kind of bark type of thing here? Let's see, ready? No, that doesn't work. So again, go ahead and go throughout your house. Maybe try to see if other things, maybe some of your toys are magnetic or have iron inside of them. Remember, if this sticks to it or any sort of magnet sticks to it, it's because it has some iron inside of it, okay? So that is our second game that you could play. And then for our third and final game, this is where we will still be needing our magnets and also that paperclip. But also, we want to have the racetrack, okay? So the racetrack here is gonna be pretty awesome because we're gonna make our car go right on top of there. So our car is gonna be our paperclip, okay? So if I just put this right on top, and if I flip this paper over, is it gonna stick onto the paper? Nope, it's gonna fall right off. Okay, but we're gonna use that force of magnetism to attract it. And all I'm doing here is I'm just taking my magnet and putting it right underneath that paperclip. And if I move the magnet, do you know what's moving on the other side? Whoa. Pretty cool, right? So you can move your paperclip. So go ahead and put it at the place where it says start. And we're gonna go all the way around the racetrack to the finish line. So here we go. And remember, all I'm doing is I'm just moving my little magnet. So you can just hold it right on top of you and just move the magnet along the way so that you can see it go all the way from the beginning all the way to the end. Okay, so here we go. Are you guys ready? On your mark, get set, and go. Yeah, that's pretty cool. Guess what? You could do it again and again and again, as many times as you want. Pretty cool racetrack that you have here, but again, the only reason why I was able to work was because of that force of magnetism, right? Where it's attracting this little tiny paperclip that has iron inside of it, all right? So those are some really awesome games that you guys can do with all of these magnets. I hope you guys had a lot of fun with that. Yeah. Pretty awesome stuff about all these magnets. I definitely had a lot of fun. I hope you guys had a lot of fun. And as always, guys, thank you for joining us. This is Mega Manoa, and I'll see you at home. Just want to give a big thank you to our guest scientist for today.
I love you, Aunt Angie.
Thank you, you did such a great job. And if you guys want to be a guest scientist, just shoot us an email and we'll see what we can do about getting you on the show with Mega Manoa. Ooh. Yeah, so just shoot us an email and then we'll see you soon.